Okay, so the example to show you what you're going to be doing for the rest of 8.2 had a lot of pieces to it. You had your null and alternative, you had your p-value and alpha level, and then you had your conclusion. This video is to show you the null and alternate part. This is the next step you should be doing after reading the problem and deciding if it's a proportion or an average. So just like confidence intervals, you had proportions and averages, means, you're going to have to do the same thing here. Read through the problem and look at the information that they give you. Okay. The example we had in the other video was the eye surgery example. And we had the eye surgery. I was comparing the new method and the old method. The new method, they wanted to see if it had a greater success rate than 30%. So our null and alternate, we were testing the pi is equal to 30%. Pi is greater than 30%. That pi greater than 30% is what the claim. They're claiming that the new method is higher, greater than the 30%. Now I use the pi symbol here. You could also use uppercase P, would be the same symbol for proportion. Okay? So this is what we're making up now. Well, don't worry about the alpha level, the p-value, and conclusion yet. First thing we need to be able to do is write out our null and alternate. If those are not correct, your p-value will not come out correct. So we need to make sure this first step is done correctly. So here's a couple examples of writing out your null and alternate and the important part of the problem that you're looking for. Okay, finding the null hypothesis and the alternative hypothesis. Okay, these are the statements that we're going to be testing to see if they're true. We want to know, is our mean equal to a value? Is it greater than, less than, not equal to a value? Okay, so those are the statements that we're going to be testing, pretty much writing out the problem in an equation. The null is always going to be an equal symbol. So no matter if it is average, and this is the mu symbol, the Greek symbol mu for average, or p for proportion. So this is why you have to decide if it's an average or a proportion before you move forward. So you use the correct symbol. The HO is this symbol, is just the notation you would put in front of your null. So people know, okay, HO, that stands for null. Now we know what our statement is. For the alternative, it's HA is the symbol, the notation, and it's either going to be less than, greater than, or not equal to. It's an inequality. You still have the same symbol mu, P for proportion. It's just going to be a different sign. The null is always equal. The alternative is going to be less than, greater than, or not equal to. That will be determined in the problem. Reading through the problem, understanding what they're asking for is very important. So for our first example, a huge goal of supermarket is to get the customers in and out of the store as quick as possible. This is the reason the express lane was introduced. Research was done and it was found that a high volume of customers run in and buy an average of 7 items. This was done in 1973. 25 samples were taken and it is now claimed that more than 7 items are being bought more often. Come up with your null and alternate hypothesis. Two important things. One, deciding if it's an average or a proportion. It has the word average in there, and by an average of 7 items. So that should be a big hint that we're looking at an average problem. We're looking at the number of items. That is quantitative data. There's another key to know that it is about an average. And the last thing you need to be able to pick out is what the claim is. And it is now claimed that more than 7 items are being bought more often. So 7 is going to be the value that we're going to have in our null and alternative. That's the number that we're judging off of. So since we know it's an average, we're going to be using the mu symbol. Our null is mu equal to 7. Again, the null is always going to have the equal symbol in it. We have the mu and the value 7. That's going to be the same for both the null and the alternative. Now, the claim is it is now more than 7 items. That more than 7 items are being bought. So that means greater than. Mu is greater than 7. So there's our null, there's our alternative. Now we can move forward. Okay, and really start thinking about what these two sentence statements mean. Okay, they mean that the average is equal to 7. Do we need more express lanes? No, because the average is the same as it has been since 1973. Mu is greater than 7. That means the average is starting to increase. The average is getting higher. Maybe the supermarket should change what the express lane is. Should they have more? Should they just increase the items? but these are the things I want you to start thinking in the back of your head. What do these statements actually mean to the situation? Matex Pharmaceutical Company advertised that the top-selling blood pressure medication holds 500 milligrams of medicine per pill. The FAC is collecting a sample of pills to test the Matex claim of 500 milligrams. So again, we're looking at a numerical value, 500 milligrams. That's an important piece for our null and alternate. That's the value that we're going to be testing. So it's a numerical value, so we know we're talking about average. Our null is going to be mu equal to 500. Again, we have the HO, mu equal to 500. Null is always equal to. Now, this statement means that the company's telling the truth. Their claim is true. It is equal to 500. You should probably buy that pill. They're being truthful. The alternative, it's not saying we're not testing a claim that it's higher, that it's lower. We just want to see, is it different? Okay, so instead of giving a direction, we're just saying mu is not equal to 500. So here we have alternative mu not equal to 500 milligrams. That would mean that the company's claim is false. Pretty a big deal here if you're not getting the correct medication. Too much can be dangerous, too little can be dangerous for different reasons, but something needs to be fixed. So here's our null and alternate for this situation. High school cafeterias say that they are providing healthy meal options for, High school cafeterias say that they are providing healthy meal options to the students each day. They claim less than 20% of the food sold during lunch are foods that are fried. So they're saying less than 28% of the foods are fried. So next time we're talking about a percentage, a proportion. And this is where you have to be very careful. The details are very important. In this case, we're looking at 28%. This time we're using uppercase P. P for the proportion is equal to 0.28. So it's 28%. And again, we're just testing to see if it's equal to that amount. They're claiming that it's less than 28%. So P is less than 28% is our alternative. Okay, the biggest difference here is that it's a proportion other than an average. So instead of using the mu symbol, we're using P. Okay, so that is important, knowing which test, what type of test you're going to be running. And one last example. The average weight of a high school freshman is less than the average weight of a high school senior. So this time, we're actually testing two different averages and comparing two different averages. There's no value here. We're comparing high school freshmen and high school seniors. So when I write this out, there won't be a value. We actually don't have two mu symbols. I just want to see the average of freshmen is equal to the average of seniors. I'm labeling my mu's, just nothing. I don't need a paragraph explaining. I just know F is for freshmen, S is for seniors. And it's claiming that high school freshmen is less than the average weight of high school seniors. So freshmen are less than seniors. And there's our alternative. Okay, so again, the null and alternate are very important. It's the first step you should be doing once you decide you're doing the type of test, either average or proportion. You need this to be correct to calculate the correct p-value to make a conclusion. Okay, so get some practice doing that, and then we'll move on to the p-value.